Osmosis is a process in which water passes through the cell membrane, depending on the solute concentration on the inside and the outside of the cell. If there's a higher level of solute concentration on the outside of the cell than the inside of the cell, it's a hypertonic solution. Therefore, water will exit the cell down its concentration gradient and move into the solution with the higher solute concentration in an attempt to reach equilibrium. If there's a lower level of solute concentration on the outside of the cell than on the inside of the cell, it's a hypertonic solution. Therefore, water will enter the cell down its concentration gradient and move into the solution with higher solute concentration in an attempt to reach equilibrium. Now, I want you to consider the following while watching this video. Why would you use distilled water for this experiment? And why would you use raw potatoes and not cooked potatoes? First, I'm going to give you a brief overview of osmosis. Osmosis is the movement of water through the selectively permeable membrane, like I mentioned before, but this is a visual example. So what you see here in figure 1, you're going to see a lower amount of solutes represented by the red dot on the left side of the beaker and a higher amount of solutes on the right side of the beaker. This is the beginning of osmosis. If you look in figure 2, you'll see that water has moved out of the left side and into the right side until there is an equal distribution of solutes within the water. Now we'll get on to the experiment. So for this experiment, the first things that you're going to need are 3 potatoes, 1 knife, 1 melon baller, 1 pan, distilled water, and salt. Next, you're going to peel the potatoes. Peeling the potatoes removes their protective barrier, which will allow you to expose the cells to the distilled water and the salt. Then what you'll do is you'll take the melon baller and you're going to scoop out a chunk of the potato in the center to create a small bowl, as you can see here. Next, place each of the potatoes inside of the pan. Use the melon baller to pick up some salt and place the salt in the bowls of 2 of the potatoes, as you can see here. Next, you're going to add water and fill about halfway up. Now, while you're waiting for osmosis to take place, you're going to wait 1 hour before you come back and see the results. Now, I want you to think, based on what you know about osmosis, do you think the water will move out of the potato or into the potato? The first potato that I'm showing you is the potato that had no salt. As you can see, there's no water in the bowl, meaning water did not move into the potato. Because there was no salt added to the inside of this potato, the cell did not have a need to move the diffused water through the potato into the bowl to fix the solute concentration. These last 2 images are of the potatoes with the salt added. As you can see, the salt has somewhat melted because water has begun to pool on the inside of the potato. When you added salt to the inside of the potato, you created a hypertonic environment. So what needed to happen was the potato cells needed to remedy that. So what happened was, because the potatoes were sitting in distilled water, they were able to absorb water from their environment, and then that water then flowed down the concentration gradient into the center of the potato to remedy the hypertonic environment that was in the inside of the potato. That concludes the experiment for today. I have a paper that I'll be handing out to you with some critical thinking questions, and we will now discuss the questions that I asked at the beginning of the video.